Hello everyone, welcome to this 11th video on Python. So in this video, I will uh, show few examples of merge or joins that we discussed in the last video. So in the last video, we just saw what exactly is left, right, inner or outer join. But here we will see a real life kind of example where there would be multiple data set and then we'll join them to get the required answers. So for that, I'll just show you the data which I'm going to use here. So this is an imaginary data set where you see we have customer ID, product, date, and year month. Now these are the customers who made transaction on these dates for these products. And we have just extracted the year month from this date which is present in this column. Then the another table is or the another data set is customer income, where for each customer we have their income and the date of birth. These two informations are available. Then there is a product data where we have products and the prices. So what is the price of those products? That information is available here. Now, if there is a campaign and there is a discount, then that information also we can have it from this particular table, where we have product price, the discount percentage, and the year month. Okay, so yeah, let's see how we are going to use in the example. So this data set is downloaded as an Excel format, and we'll read it in this particular code. Okay, so we have seen this in the last video that these are the important arguments. So we'll just start with loading these two libraries. In fact, this will also not be required in this particular case, but yeah, these two libraries are loaded, and then we are reading the first table, first sheet from that Excel sheet. So for that, we are using this read Excel function. So this merge is the file, merge.xls is the file in which the first sheet is the transaction. So once it is read, you can see how the first five rows look like. So we have this customer ID, the products, the date, and the year month. But yeah, this date, it may not look like that it is in a proper format. So for that, we'll just extract the first 10 characters from each of these rows, and for that we'll use this lambda function and apply it. So but because this date is read as a date time column, we'll first have to convert it into a string and then extract these values so that it is in a this kind of standard format where we have the year, the month, and the days after that. Okay, so once this is done, we'll read the another table which is the customer table, where we have the customer IDs, the income, and the date of birth. We'll just treat the date of birth as well in the similar way to extract the first 10 characters. But yeah, before doing that, we'll just uh, convert it into string first. So once it is done, you see the date of birth changes from this values to these values, and then the third sheet had this product information available, all the products and their prices. So we are reading that as well, and it's a very simple table. And then we have the fourth sheet, which is product season. So we have the product, the prices, the discount, and the year month in that particular sheet, the fourth sheet. So yeah, let's answer some question based on these four sheets. So first of all, let's get the age of the customer in the transaction data. So we have seen that the transaction data has the customer ID, product, date, year, month, those kind of information, and the customer data had the age and the income information. So to get that age in the transaction data, we will have to merge these two data frames. To do that, we'll use this merge function. So you can observe that first I have taken transaction data because we have to add some information in this particular data frame. So the first argument is this transaction data frame. The second argument is the customer data frame because we have to pull information from that particular data frame, and both these data frames have customer id in common. So we'll write on customer id and then how equal to left, because we don't want to get information from customer who didn't do any transaction. So we'll just, and we don't even want to, that's why we are not doing right join. But yeah, we also don't want to just restrict it to uh, common customer between these two tables. That is why we are not even going for inner join. We are doing left join so that for all the transactions available in the transaction data, if we have customer information, we'll get that and we'll lose no transaction from our transaction data. So that's why this left join is done. So with these lines of code, the data, both these data frame is joined and we have a new data frame transaction age, and this is how it looks like. So we have customer id, product, date, this is transaction date, year, month of this transaction date, income, we also have the income and the date of birth. But now we have the date of birth and we have to calculate the age. So to do that, we can calculate the age at this point of time, at the time of transaction for these customers. So what we can do is we can uh, calculate the difference between these two dates just by subtracting, and then we'll just pull dot dt dot days to get the number of days, and when we divide it by 365, we get the number of years. But yeah, before doing that, we'll convert it to date time, because let me show you, because these two columns, because of our earlier transformations, these two columns, the data type is now string. So let's see, transaction is not the types. If you do that, you see, date is again an object and dob is an object. So we can't subtract two objects. So we are first converting it into date time, and then we are subtracting to get the number of days, dividing it by 365, and at the end we are rounding it as well so that we don't have too many decimal places. It is not that useful. So after doing that, this is how the data set looked like. So at this point of time, when this transaction was done, for this customer id, the age was 32.3 years, and that is uh, achieved by subtracting this date, uh, subtracting actually date of birth from this date. So it's 2013 minus 1981. Okay, so we can get this age. And this is again because this information was available in another table, so we had to join to get that info. And we can also get the income as well if you want to use that. It's all available when the join was done. But yeah, if you want to use, you can use that. Now the next question was to get the price of the product in the transaction data. So now with after first join, we have this transaction is data frame, and what if you want to add get the price of the product as well. So just right now we'll just join it with the product data to get the regular prices. We'll not get into the discount thing right now, but yeah. So for that, now in this table transaction age, now we are going to add information from product table. And what is the common between these two tables? Product. So we have multiple rows for these products in the transaction data, but in the product table, these are just unique values. We just have the five products and then the prices for those five products. You can see that. So there is no duplicate here. So it's like many to one kind of join. Okay, because your transaction data has multiple products, and in the product table you just have one information. So it won't change the number of rows, etc. as well. Yeah. So after join also the number of rows will remain the same, and that is very important. We should always check that. If you're not able to identify before merging two data set, whether it is one to many, many to one, or many to many kind of join, then just by looking at the number of rows we can easily identify that. So yeah, so let's look at the number of rows present in this transaction each first. So transaction, let's check the number of rows in transaction. So transaction has 181 rows. Transaction each has 181 rows. And when we are adding this price information in this cell, so now we are getting the price is also added here. So let's look at the number of rows after doing this operation. So so here also it is 181 rows. So it's essentially many to one join. Okay, so there is no increase in the number of rows, and it will only happen in case it is one to many, if you, or many to many kind of join when you are doing this left join. Now we'll look into the other table as well, where you had price and discount, everything was mentioned there. So this third question is add price and discount by season to the transaction data. So we'll do left join first. And now this is interesting because the transaction data you have product and year month on which the transaction was done. And in the product season data also you have product and year month. So for that particular period, year month period, for that particular product, what was the price and discount? So those kind of information was available here. Let's look at that particular table once more. Yeah. So product, price, discount, and year month. And this is how the transaction data is, which we have seen earlier as well. Product, date, year month. So to join these two tables, we should not do it just by joining it on product, because again product has this product season. Let's look at this product season. So if you see, if we do value count on this particular table on this product, see there are multiple rows. So and in your transaction also there are multiple rows. If you join, the number of rows will increase and you will have many to many kind of join, and it won't be correct, because if you want to get the price for a particular season, then you should not join it on product, you should join it on product as well as the period on which you want to look at the discount details. Okay, so for that we are again using the merge function, but here we'll not use on. We can use that in fact, but yeah, here just to show that we can also do the same by using left on and right on as well. And this is quite useful. I generally do the joins using left on, right on most of the times, because even if the column names are different, if you specify the different column names as well, it does work. So with this cell, in this cell we are joining transaction with product season, where the keys on transaction table are product and year one, the combination of these two, and this product season also we have this combination product and year one. So once we run this, This is how the results look like. We still have 181 rows, but yeah, if you see, for many of these, price and discount, this information is not available, because here it is null, because a product 202105, there may not be any discount, so we are not getting any price. Okay, so we'll see how to handle this. But yeah, let's see what if we do inner join. So this is when we do left join. 181 rows are there. So when we are doing this inner join, where only the records where both these combination are matching, so all those cases where we do get this price and discount, only those records will be present in the output. So with inner join we are getting only 10 rows. So even if the product table has multiple rows, only 10 combination were matching with the transaction data, and the discount was available for only those 10 records. So the B product which was sold in this period, the price was 48, and which was after this 15% discount. Okay, so because this most of, so only 10 out of 181 we have this information available. For 171 rows we don't have. But yeah, I mean the transaction is there, so it won't be like that it's without price. So to get the price for these records, what we can do, we can again use the normal or the regular price information which was available in the product data. So we will first we'll run this cell again with left join, and after that we'll again join this data transaction underscore ps, where we are getting information from product season, which is like this. The same cell is again copied below, so price and discount are added here. Okay, so after doing that operation, we'll again join it with the product table, and here let me just get an output here. So let's check this data frame. So with this line of code in transaction underscore PS, we have this much information till price discount with all 181 rows. Now, what we will do, we'll add more information from this price table, and for that, we'll join it with product as a key. So on product, this product table is added. How left? So we are again just adding the information. But here we'll add use one more argument here, which is suffix, because we already have a price column, and the other table, this product table or data frame, also has a price column. So otherwise, the names will modify by default with underscore x underscore y. But to identify, just to keep this as same, the price column which is available in your data frame initially will keep the left part as blank in this suffix argument, and the right part, the other part, will just mention underscore p. So when we run this, the output looks like this, where you can see that we have a price from the price season table, and we also have price which is normal or of the regular price coming from the product table. But these we can easily identify that yeah, this is coming from the product table with this suffix underscore p. Now we now have two price columns. So to fix this, we'll apply a logic that wherever this price column is null, we'll add the price from price underscore p. So we'll just update this price column. So you see we are applying a lambda function where it is looking at each row in the price underscore p. It will add this value to price column. So it's like price underscore p if this price column is na. Otherwise, you just keep whatever it is present in the price column. So with this line of code, in the final table, this is how the values will look like. And we are also just filling up the nulls with 0 if it is present anywhere. Okay. So now you can see this is how it looks like. So wherever it is, wherever, I mean, here you can see all the first 10 rows were null. So it's like that. But otherwise, in the next row, if you see, there's a discount. So these two prices are different. So this is how we have finally treated this price column. Now we can do a few more things. If you want to get some summary out of this data set, we can easily do, for example, revenue by year, month, and count of customer. So for each transaction year, month, what was the total revenue and how many customers were present. So if you want to get that information, we can easily do using group by, which we have discussed in the earlier videos where we discuss aggregating or summarizing the data. So with group by on year, month, and we can use this aggregate part to get those aggregations. So we are counting the customer ID and we are adding the price. Okay, so this is the total revenue and this is the total customer count. And here it's kind of an assumption that yeah, quantities is one only. So there are those kind of products where you don't sell multiple, it's just one. So that is assumption because it's again it's not a data set from available anywhere. It's just a randomly created data set. And then this revenue, we can also get revenue by product and count of customer. So if you just summarize it on product, then we can see that a 40 customer has bought a product, B was bought by 35 customer, and total revenue was 1036 for a product A, 2258 for product B. So this is how you can get this. But yeah, I hope this example where we have seen uh, that how we can join on one column and multiple column and why we are doing left join here. I hope this is clear in this video, and I hope this is in useful to you. So do like the video, subscribe my channel. See you in the next video. Thank you.